This is the whiteboard for today. This is the formatting for your help sheet. These are your homework problems for tonight. And at the bottom of the screen, do I have it? No, I'll get them in there right now. And now the whiteboard file will also carry the answers for all these problems. This is an example of a formula of a hydrate type calculation. I haven't shown the end part of it though, and that's shown in another scene in just a minute. This screen carries a hydrate problem where we actually worked some numbers. And you can see the whole thing here. I had everybody in the class copy this screen directly onto their help sheet. And the formatting for the help sheet is right here. This is where we did some different types of problems. Okay, in each case, we're going from the guy on the left to the guy on the right. And I quizzed every student on how to work problems where we start with the thing on the left and go to the thing on the right. And then we use this path. By the way, these guys are all paths. And then we went to this path where you'll notice that we have three fractions. And to do those three fractions, you'll note that this is always going to be the given, and it will be over 1, whatever the given amount is. And then this guy will be on the top of the next fraction, with the guy behind it is going to be on the bottom. And in this case, since we are in periodic table territory, the bottom part of this is going to get grams from the periodic table. And particles will always be avo, and on the bottom we have 1 mole. So when we do the reverse, which is starting with particles over 1, that's the given. This guy will come from the avo number, that's the moles, which is always going to be 1, with the avo number on the bottom for that fraction. The third fraction will always have grams, and now we are in periodic table territory. This is avo territory. It's just backwards from the first problem. And so grams will be on the top in this last fraction, and we'll get those grams from the periodic table, and the bottom will be 1 mole. So this is a quick once-over of what we did today, and we'll do some actual problems a little bit later. Okay, we're right during class now, and showing the formula of a hydrate screen. This screen does not give you the final calculation and how to do it. But you'll notice here 2 very important things. Always in the problem, you have to be given the grams of dry salt. This is after heating. You're always going to have to calculate, well, usually you'll have to calculate how much water is there. And you get that by subtracting the grams of salt from the grams of the hydrate, which is the salt and the water. So once you have these 2 numbers, all you have to do is convert those from grams to moles. And the grams of water are on the top. And so that final calculation will look like this. So we have moles of water, and we have moles of salt, dry. When you divide those 2 numbers, you're going to get that X number, which is right up here. Okay? So that's the number in the formula of the hydrate. So it would be magnesium sulfate, and then whatever the number X is that you get from this calculation right here, which comes from converting these guys into moles, and then that number plugs in to the formula of the hydrate. And so that formula of this hydrate would be magnesium sulfate, whatever X is, which we haven't calculated here in real numbers yet, and this would be water. So that X is what this calculates. Okay? All formula of the hydrate problems have to give you, at a minimum, this piece of information and this one. Now, I've got another one that I did during the break, or during lunch actually. This is one where a student came in and actually wanted to try a formula of a hydrate problem. So I made up some numbers, and they are not the exact number that you would get if you were using a real experiment and you did good work. This is going to give you a number that's way off. So at any rate, when you do these calculations, you're going to find out that they're really not that hard. Okay? This shows what I call the path right here. The path is telling you where you're starting and where you're going. In both cases, we're going from grams to moles. So this was the water, and this was the dry salt. And we got them into moles, and then this guy over here is the actual final calculation. And we don't have the actual number for that, but you could work that in your calculator and get it very easily. Particles can only be atoms and molecules, I'm sorry. And then moles always deal with AVO. If you're on the AVO side of the big picture. Ooh, okay, you guys here can't see this. Now you can see it. Pathways that I'm going to show today in this video are going to help you considerably in calculating your problems, because it gives you a path to run on, and once you get used to it, you'll find you're going to get these problems right every time. So my promise to you today is everyone that learns and watches with interest and writes things down today and listens, you are going to improve your scores on tomorrow's test by at least 20%. 20% higher than when you walked in here. I guarantee it. Okay? So this is a worthwhile thing to do. All right. This is the master. The master, let's get this down even more. Okay, the master includes how to do all the problems that you're going to see that have calculations on tomorrow's quiz. I know that for absolute certain because I'm making the quiz tonight. I have the test bank all secured, so I know exactly where I'm getting my questions from, and the number of versions that I make is up to me to know and you to guess. Okay? But calculations, PT stands for periodic table. AVO is the 6.02 times 10 to the 23rd equals 1 mole. And that takes you both ways in these kind of calculations, where we start with moles and go to particles, or we start with particles and go to moles. So let's go ahead and get this down, and let's start working on, or show you first of all what you're going to do during the period while we're talking about this first screen. I'm going to uncover everything so you know what you're going to be copying. Don't try to copy them right now. Okay? This just tells you how they're laid out. First thing, arrow will always point to the given. All right? So, Coco, you go up first. And Coco, if I've given you grams, what are you going to do in the next fraction to get to moles? What has to be on the bottom? Are you going to put moles on the bottom to cancel your grams? Okay, where will the grams come from? And I want to point out again, AVO territory is over here when we're going between these two, and periodic table is over here when we're going between these two. So, what are we going to have on the bottom? From the periodic table. Excellent. Okay, that's all there is to that. Okay, if you've copied that down, you've got part of the puzzle here to show you all of the possible problems you could have tomorrow. All right, now, on this one, we're going to start with moles. And Michael, you're on. So, Michael, if I'm starting with moles, what has to be on the bottom of the next fraction? Okay, Michael, what do you say? What has to be on the bottom of the next fraction so that I can get grams? 1 mole. Excellent. And where are we going to get the grams that we put in there? From the periodic table. Okay? And we'll do some actual examples in just a minute. This is just preliminary. Okay? Just getting you used to pathways. Okay? What I call pathways. So, now we're going to do moles as the given. And Johannes, would you tell us, are we in AVO territory or are we in periodic table territory? AVO territory. Excellent. What has to be on the bottom so that we can get particles on the top? What? Very good. And what's the number going to be on the top? Very good. This 6.02 times 10 to the 23rd. Excellent. And that's all there is to that problem. Notice, we've done 3 examples. How many fractions were there in each of these examples? 2. Once you've written the pathway, guess what? You know how many fractions are going to be in your calculation. Is that cool or what? Yeah. Okay. Let's go one more of these. Okay. This time we're going to go particles. By the way, I'm noticing everybody that's doing this is coming up with a big smile after they've been called on, and they answer correctly because everybody's answering correctly. It's great. Nare, you're up next. I'm starting with particles. What has to be on the bottom of this fraction to get moles? Particles. So what is that particle number going to be? Yes, you do. You know that number. Yes, you do.
Oh.
It's the big honking number. Sure you do. Yeah, you do. Oh, who can help her? 6.02 times 10 to the 23rd, and that's the guy that goes on the bottom. What goes on the top? Okay, on the periodic table, you get the grams that equals 1 mole. Okay? When we are going to moles from particles, AVO is the number of particles that equals 1 mole. And so, essentially what you have is 6.02 times 10 to the 23rd particles is equal to 1 mole. And so the mole is at the top and the particles are at the bottom. If you can't remember that number, I would recommend you put that on your help sheet right now. Okay? We've used that a lot. Yeah. Under particle, it's particle over 1. That's our given. Particle over 1. Okay, however many particles it is, it'll be some number with a power of 10, usually, unless they're asking you about what does one atom weigh. Okay, which is a tough problem if you've never thought about how that works. And then the moles here is coming from this equality. You see? And that becomes your fraction to do the calculation. And so because particles is here as the given, it has to be underneath moles on the second fraction. So it will cancel, right? And then this guy will be always 1 mole, no matter what the atom is. With the ovo territory, it's really simple because it never changes. Now you know what it sounds like when the fire alarm goes off. Okay, here we go. Now, here's the next problem type. Okay, this time we're going to start with grams. That's the beginning of our path. Elizabeth, you're on. What's first? What? Grams. Okay, so grams over 1. What is on the bottom of the next fraction that is going to allow us to get moles? And cancel the grams. First of all, ask yourself, what territory are we in? Okay? Are we over here or are we over here? Okay? So, where are we going to get the grams from? Or, we're doing this one. We're in particles. Okay, we're in particles, so where are we going to have to be? Periodic table or ovo? Okay, that's what these guys are all about. Okay? So, down here at the bottom, what is the number of particles? Number of particles. Uh-huh. Okay, and the number of moles? Very good. And now, when we go from moles to grams, where are we going to get the grams from for the number? Periodic table, because now we're between moles and grams, you see? So that's periodic table territory is what I'm calling it. Whenever we're going particles to moles or moles to particles, we're in Avo's territory. 6.02 times 10 to the 23rd equals 1 mole. Okay? So, particles got us from here to here. From here to here is going to be the periodic table. All right? On this screen, what we're going to do is some actual examples. And so I'll be calling on people to actually solve the problem with some simple numbers. Okay? So, Andrea, you're going to be up first on this one. I am going to take this problem type and I'm going to give you 5 grams, and you need to tell me what you want for the atom. What atom do you want to use? Anything on the chart.
Be.
Be, beryllium. Okay, so you're going to do beryllium atoms. Or beryllium atoms, yes, that's 5 grams of beryllium atoms. And what is my find? Oh, thank you, that's boron. You're absolutely right. Thank you. Look at where my red arrow is. What are we going to? What's the find? Moles. Uh-huh. You see, the last guy in the path is always your find. That's how you use these paths. Okay? So the find is how many moles of beryllium. All right? Let's start with the first fraction. Okay? And get the grams to be on the bottom of this fraction? Very good. You're looking at the right place. She's looking at the periodic table.
9.01.
Okay, 9.01, that's fine. And this is, whoops, this is on the wrong place. 9.01 grams of beryllium, and what's on top? 1 mole. See, the moles are always going to be 1 with this kind of a fraction. Anytime there's a fraction in the middle where we're going to moles or coming from moles, moles is always going to be a number 1. Okay? And we're done. That's it. That's all there is to the problem. Okay? What should my given be in this problem? Very good. Grams. Yes, indeed. So, we're going to have grams. Oh, no. It's not grams.
Moles.
The moles. Yeah, the red arrow is pointing to the given. So this is the moles. And let's call this 7.3 moles. 7.3 moles of, name an atom. Your choice.
Potassium.
Okay, potassium. And what are we supposed to find?
How many grams?
Grams. Excellent. And we're going to get the grams from where?
Periodic table.
Excellent. Periodic table. So, start our first fraction.
39.
Oh, no. No.
Um,
First fraction is always given over 1.
30, no,
Given over 1.
given over 1.
Uh-huh. What's the given?
9.3.
It's actually 7. I know it's hard for you to see. So, and my writing doesn't help. Okay? 7.3 moles of potassium over 1. All right? Now, what has to be on the bottom of the next fraction?
So, 7.3.
7.3 is our given. Now we use the number from the periodic table. What's the number in the bottom of the potassium box?
39.10.
What?
39.10.
Okay, 39.10. And that is going to be your grams side. How many moles is that? See, that's the molar mass, 39.1. You got that off the periodic table. And how many moles is that equal to? Yeah, 1 mole. And this is potassium, and this is 1 mole of potassium. And now all we have to do is multiply 7.3 times 39.1. Right? That's it. We're done. How do you like that? Pretty easy? Yeah. Okay. So, we just did 2 problem types. Both of them required the periodic table. In one case, we were going grams to moles. In the second case, we went moles to grams. Now, we're going to do another problem. And this one will, let's get rid of these guys. Now we're going to go moles to particles. And for that one, we're going to get Sophia. Okay, Sophia, got your, what are we going to use now for the given? I will give you 4.6 moles. You pick an atom. Inside back cover of your textbook would be easiest to work with. So the given is moles. Helium. Okay, helium's a nice number, or has a nice number. And we're supposed to find grams of helium. Okay? Oh, not grams. Whoops. You don't need a periodic table. This is particles. Okay, so this would be helium atoms. Okay, because that's the end of the path. You see that? Okay? So, What's our first fraction? Good. 4.6 moles helium over 1. All right, what has to be on the bottom of our next fraction? We're looking for atoms now. Whose territory are we in? See, this is the PT area. Are you looking? Over here? Oops. Here. Moles to particles. Yeah, okay. So we got particles and moles. Those are the two parts that we're dealing with. So we're starting here and we're going to here. That's OVO territory. If we were going moles to grams or grams to moles, we would be in whose territory? Or what territory? Periodic table. Yeah, when we're doing these guys. Okay, so we're going moles to particles, and for that, we use this guy. And since we're talking about helium, this would be helium, and this would be helium. Now that we have that fraction, we know, or now that we have that equality, we can make that into a fraction. So which side has to be on the bottom? The particles or the moles? Very good. So we put moles on the bottom. How many? Okay, did you say that because someone else said it? Good, all right. And what's the number? And that's it, we're done with that problem. Nice. Okay, let's do the next one. Pirelli, you wanted to do it? All right, let's go for it. Okay, we're going to do particles. For that, let's see, let me get all this stuff out of here. Folks, every problem makes it easier, doesn't it? Yes. What? You can do the next one. Absolutely, no problem. Okay, Pirelli, I'm going to give you, since we're talking about particles, here's your number. 8.3 times 10 to the 20th atoms. You pick the atom. Magnesium. Okay, we got magnesium. And so what are we supposed to find in this one? The moles. Okay. Moles of magnesium. All right, Pirelli. What is our first fraction going to look like?
8.2 times that over 1.
8.3 times 10 to the 20th atoms. Mg.
Over 1.
All right. And what's our next one? What has to be on the bottom? Atoms or moles? Atoms, of course. And what's the number? Yep. Mg. And I'm going to work this. Let's work the whole thing out. What's on top? 1 mole of magnesium. Okay. Are we done? Does it look good? I've got to stop the recording because YouTube only takes it up to 30 minutes.